Hello guys, how are you? Welcome back. Yana ra simolla ra go lebella tsone ke gas law. Re ta simolla ka pressure law. Pressure law ke yone. So pressure law, it states that the pressure of a fixed mass of gas at constant volume is directly proportional to its temperature. I get? Yes. From P over T is equal to constant. Taking T to the other side, we get this. P is directly proportional to T at constant volume. P is directly proportional to T. To explain this, we shall look at a metal box. Volume will not change. Okay? So the metal contains a what? A gas. So mogging particle. So what is happening to these particles? How gets our temperature? Our temperature gets this particle is going to move at high speed, hitting the walls of the container, thereby increasing the what? The pressure. Ke sone se se leng teng hela gone. Yaanong se ke batla re se ire ha ke gore re go lebella go simulation yone particle ya ke re ta ira ile one pele gore re kgone go bona di le dintsi ka re ha o kgone go bona sente gore go iragala eng. So re ta irisa yo one mme tsone ya be di le dintsi a ke ya no ra go lebella gone gore ha re oketsa temperature go iragala eng ka pressure mme gape volume ya container e sa change a ke yes, let's go there and see. Yes guys, simulation particular we want to hold something constant. What do we hold constant? Volume. Volume ya change, okay? Yes. Ya no ra go oketsa temperature. Re batla bona re pressure ga ta iragala eng ka yone o ilebelle. O lebelle le temperature ka. So go re oketsa temperature ka eng by heating. Okay? Yes, kana ke simolola ke khula pele. Yeah, let me cool a little bit further. Can I got a clear thought? Pressure thing more container ring. It is due to this particle hitting the walls. I get your next temperature particularly. Didn't remember your diligence? Not a thing they want. Super diligence after re explain. Or diligence ya gonna give a rang of followers and speed is okay kana so kutsegile okay yes so ke o ketsa temperature by heating o lebelle temperature o lebella le pressure yo ketsa ga go le kae yes o lebella gape le particle gore speed sa yone sa change kana ya which is its kinetic energy level temperature o lebelle le pressure the speed of the particle kana horita the walls of the container say in a second. I get mona konyane wa bona re particle ya no hita the walls gapetsa mona go ikhutshwana ka gore bona lebelela le pressure re tsama kae because this particle is busy hitting the walls at constant volume. I get temperature pressure I get this is what we wanted to show, but in reality the particle so that's it. I will link a white body a little bit further. More white body and pressure law. So that's we are thought. For simplicity, we consider a simple particle in a metal box. Metal volume. The initial pressure and temperature P1 and T1. The initial pressure and temperature is the initial pressure and temperature P1 and T1. The particle moves at a particular speed to the left. Upon hitting the wall, it bounces back to hit the right side of the wall. Simulation. Suppose we heat the metal box to increase the temperature of the gas. That's exactly what we did. Temperature the average kinetic energy of particles. So temperature is the measure of the average kinetic energy of particles. So particular increasing the temperature to T2 increases the kinetic of the particle. Because when a particle move faster, take kinetic energy. The particle will move faster, which means it will hit the walls more frequently. And we saw that. It will hit the walls more frequently with greater force than before. These frequent collisions at high speed over the same distance, because volume is still the same, increases the what? The pressure. Guys, with regard to pressure law. Pressure law, when I was P is directly proportional to T. Okay? Yes. Well, level the graph of pressure against the time. Guys, how gets a temperature. Pressure ya gets a volume means is a change. I get some simulation. Well, what are graph at is sensor in no, ki super center or similar from the origin. Origin. Oh, yes. So, kione graph ya rona inna hela ya pressure versus temperature. Look at that temperature baka pressure ka go tshwana hela graph ya go 19 The pressure versus temperature graph shows that indeed at constant volume pressure increases with temperature. This is what we are talking about. This is what we saw with simulation. Well, the next law is called Charles' law. It states that the volume of a fixed mass of a gas is directly proportional to its absolute temperature if the pressure is kept constant. What the volume and temperature guys. We say okay before kanya thata gore re imagine re ke re tabogele go simulation re go iponna ke tara ke tlhalosa so se leng gore o se bone le wena ka matho a gago ya re go simulation ga kologela ke mo go leng constant yan what are we holding pressure ke ga go bona ke VDT ya ona pure so pressure ke yone go ra gore e ska ya change bero ke za temperature re be re bona gore go taira ga le ka volume. Okay, good. Okay guys, re go rogile mo simulation tsa rona re batla go supa gore go iragala eng ka volume le temperature ha pressure ntse ile constant ya nkie ke ira constant okay pressure ra rona ke e constant a re bona re ya no go iragala eng ka temperature le volume ke tawo ke tsa eng heat ya tawo ke tsang temperature be re lebella re volume go iragala eng ka yona bona re container ya oketsega pressure ra ke ile ga change 544 kilopascals bona re volume ya oketsega temperature good. This is what we wanted to show. So volume ya oketsega guys ya oketsega because pressure rents is constant. Pressure is constant. And volume is constant. Volume is oketsega, temperature is oketsega. Wa gonna le increase in pressure because volume is oketsega gore ya accommodate kinetic energy ya particle gore just ka ja hit the walls more frequently be go change pressure. Okay, so yone Charles law ini are willing ka kwa ko whiteboarding re go tlhalosa a little bit further. Well guys, re gorogile mo white body ya ka o bona V is directly proportional to T. Ela ka re bone go di simulation ha temperature e oketsega volume e ira ile yone ya oketsega ha pressure e le constant. Ya no ha initially ne re le ha V1 T1 temperature e leng gore ke average kinetic energy of these particles, volume being the volume of this balloon. Now we wish to increase the temperature by heating or exposing the balloon to the sun, and as a consequence increase the kinetic energy of particles. How gets a volume temperature kana heater ni an container o bone the kinetic energy of particles ya gets a move fast again. Good. The pressure on the walls of the balloon should not be allowed to change. That is to say, no increase on the frequency at which particles hit the walls of the balloon. The only way to keep pressure constant is to allow the volume to increase. Okay? As the kinetic energy of particles increase with temperature, particles will move at high speed but will then move a longer distance before hitting the walls of the balloon, thereby keeping the frequency of hitting the walls the same, hence constant pressure. At final volume V2 and temperature T2, particles cover a larger distance at high speed to keep the pressure constant. So what are particle tata ke tabua ka nako gongwe gore nako e itang wolo e bea go itale wolo ya lekana le ka gore ka kwa container le ne le nyane ka kwa nentse yang container e tona yang. Okay? Yes. Well, yana re batla lebella graph. The graph of volume against temperature. Absolute temperature is a temperature measurement on the absolute scale, where 0 is absolute 0. Right? So, absolute temperature scale, or the temperature is in Kelvin, so I get Kelvins. Yano. A graph 9 nayang. Remember, temperature I work at le volume. Temperature I work at volume. So kakwano ki Celsius scale, haki absolute temperature scale, haki combined Kelvin and Celsius scale. Yes, so it's similar from the origin. Yes, in Nayana. Leha Yahona from the origin. Yan on this side, Yahona. Yes. Highly 0 kelvins. Highly 0 degrees Celsius. Highly mangha. Highly 0 kelvins K. Highly mang. Highly 0 degrees Celsius. 9 degrees Celsius in namang. Negative 273 degrees Celsius. This is what we need to understand. Yeki absolute 0. Ki 0 to tawa marua 0 kelvins. Okay. How do we do that? Or convert from Kelvin to degrees Celsius, kind of vice versa. Okay guys, this is how we do it. From Kelvins to degrees Celsius, we subtract 273. So 10K to degrees Celsius, we subtract this vein. Okay, therefore 10K is equal to negative 263. Then from degrees Celsius to Kelvins, we add 273. So 0 degrees Celsius to Kelvin ora re ke bokae? 0 plus 273 e nna 273. So 0 degrees Celsius ke 273 kelvins. Ra bona ke good. Well, ke decidile gore ke kwale ka dikhara tse di sa tshwaneng gore re kgone go followa sente. So because this is a combined Kelvin and Celsius scale, so ya bo blue yo ke Kelvin scale, so ke 0, which means ke absolute 0 tota ke 0 Kelvin. Then hana ke 270 kelvins ke 0 degrees Celsius. 0 Kelvin ke negative 273 degrees Celsius. So ke tsone digraph tsa teng tsone tse. So go ra re a re heleng gone ha ka this lesson re ta kopana mo lessoning e latelang gore ta be re lebelela Boyle's law e leng gore ke yone e leng gore yone tota include di-calculation yena tse pedi tse ga di na a re calculate sepe akere. Yes, sone hela go ka botswa gore go iragala eng, you have to explain things ka kwa ra go explain re calculate ko Boyle's law. Okay, thank you guys, let's meet on the next lesson.